All right, we're gonna do a couple of examples. Sorry, this is coming out a little late than I expected it to. A little sick, so I'm on. So that's part of the reason. But hey, so we know what's going on here. We've got magnitude and direction of the force exerted by the floor on this rod. There's a hinge right here, right? And I've got some angles measured out, everything like that. But again, let's simplify this by drawing just the beam. And actually, I'm gonna do a little better job drawing that so it's at a more realistic angle, given what. All right, we've got a force of gravity hanging down. We've got some mass hanging down there. We've got a force of gravity hanging down at the middle. That's the mass of the beam. We've got a tension force. I don't know why I drew it so long, but going back that way. And then we can guess the force here has to be upward and it has to be to the right. So we got some force of the hinge, right, going up like this. The force of the hinge. Up that general direction. Okay. The question is, what is the magnitude and direction of that force exerted by the floor on the rod? So there's two things we don't know. We don't know there's actually three things we don't know. We don't know the tension. We don't know the force of the hinge. We don't know what angle the force of the hinge is at. And so it's going to behoove us to find the tension first. So we're actually going to go out of order here, and we're going to make the here's going to be my axis for the torque equation. All right, and this is going to get me rid of this hinge force, which I don't know the angle or the magnitude of, and just have these three. So I've got torque equals 0, which is equal to R. Oh, it's called well, it's FG1, FG2. R1 cross FG1 plus R2 cross FG2 plus R, say T cross tension. So first off, what are these R's? I actually did not give you the length of the beam. That's okay, because I know what they are relative to one another. These two are both the same, and this is half of it. So I can say this is basically R FG1, this one half R cross FG2 plus R cross T. All right, so what is that going to set up, make it, or come out to be? So I've got R cross FG1, so that means it's R, and then the FG1 is going to be 10 times 9.8. And then we have to have the sine of what angle? Now that's this angle right here. Okay. Well, I know this angle down here. Now this is 60 degrees. So that must be sine of 30. And then I've got R, or 1 half R. I'm definitely going to run out of room on this line. Right, times 5 times 9.8 times also sine of 30. Right, and then I'm going to have plus R cross T. So this is going to be RT. I know what this angle is. It turns out this angle is also 30. Okay, you can do that because this, if this is 60, this is 120. So that means it's here angle 30, 30, 120. All right, now if you've been sort of paying attention, you might be asking yourself a question: wait, what about positive and negatives? And yeah, I didn't take that into account. So let's get rid of these signs, and we'll make up our minds about the signs. So, so I guess what I'm going to do is I'm going to say that this way is positive. So that means that this is negative and this is negative. Okay, my R's are going to cancel out, right? So I'm going to get 98. Actually, I know what that is. Right? I don't need to write out 98. This first term, 10 times 9.8 times sine of 30. This is going to be 49, or negative 49. Right? Minus, this is going to be 1 half times a half, 1/4 of 5 times 9.8 times, R is going to cancel out. This is going to be 12.5 plus 1 half T. 0. T is going to equal 122.5. Now I need to do F net. F net X. Only two forces, right? We've got the hinge has a horizontal force on the rod, right? And the tension. So the tension, right? This is going to be this angle right here. That angle's 30. Hopefully you can figure that out. So I got F hinge in the X direction minus T cosine 30. That's going to add up to 0. F hinge X equals 106.1. Then we got F net Y, which should be F vertical or hinge Y direction equals, or not equals, that too. Minus FG1 minus FG2 minus torque sine, or tension sine 30. If you do this one, you get, I'm actually just going to write it out. You get F hinge Y equals 208.25. So I've got these two values. If I wanted to find the, right, I can make a triangle, right? 106.1. This is 208.25. That means that this is 2. If you do the Pythagorean theorem, this is 234. And so it's 234, 63 degrees above horizontal. Okay. And that's my answer. The force, magnitude direction of the force is to the floor. All right, second problem. We got a pesky ladder problem. I don't even know why it's there. So we got a ladder leaning against the house. So let me write this out, draw this out here. Ladder or house, ground, ladder. This is 3 meters. This is 4 meters, right? Because it's a 3, 4, 5 triangle. I was trying to be nice about that. And we got some person here, and they get up high enough up this ramp that this is going to start to slide. So let's look at the forces, right, on the ladder. We've got the wall, the force of the wall, and the force of the person, FG person. We got the force of the ladder, FG ladder. We've got the normal force from the ground, and we got the force of friction from the ground. Okay, so why is there no friction from the wall? This is a really good question. The answer is because then you get a differential equation. So I don't want you to get a differential equation, so we're going to make the wall no friction. Okay, it's a little lazy, but whatever. What you going to do? First thing, this is actually not doing a torque equation, right? Because we only know this force, right, at the moment. I'm going to set up my F net equations. F net Y equals FG person. Actually, those are both negative. Let's start from the over here. Fn minus FG person minus FG ladder. Fn is going to equal 110 times 9.8, which is, actually I don't know what that is. I can do that in my head. Hang on. I can do this in my head. 980 plus 98. Yeah, I can do that. 980 plus 98. 1078. Yeah, there it is. Okay. And then we get to F net X, which is F wall minus force of friction. And this is a force of friction max, right? This is the static maximum. So F wall equals 1078 times mu s, which is, it turns out, 646.8 newtons. All right, how far up can they get? So I'm trying to find this R here. So it turns out the best way to do this is, right, is I want to eliminate one of these, either that end or that end. I'm going to eliminate here because there's basically all the forces at a weird angle and I have to calculate all that, but I can eliminate it. So I'm going to make my axis here, So this means that my torque equation is going to be, and I guess I need to say rotating like this. Let's make this way positive this time. I don't know why. It's going to be R wall. Oh, why am I writing that so big? Cross, right, F wall plus R person cross F person plus R ladder cross F ladder. Okay. R wall, this is 5. A force of wall is 647, well 646.8 times sine of theta. That theta right there. Okay, and then we've got plus R person, which is our unknown. R force of the person is 110, or 80 times 9.8. That's 784. I'm going to use phi here for this other angle, right? So this angle right here, that's going to be phi. Plus 2.5, which is the R of the ladder, times 294 times sine of also phi. All right, here's the fun part. Sine of theta, I don't actually need to know it. I don't even know what theta is. Because this is right going to be, this is going to be 4/5. That angle is the same as that angle. So 4/5. Sine of theta is 4/5. Opposite of rho bonds. These are going to be minus. I guess I should have had that in the previous line. Shouldn't I have? Yes, I should have. Okay. It's going to be R 784 R times 3/5 minus 2.5 times 294 times 3/5. And we should get that R is equal to 4.56 meters. So the person can almost make it up to the top of their ladder before it starts to fall. All right.